students, so welcome to today's session. In today's session we will be talking about data types and operators which are used in Java. So talking about the different data types which are used in Java, we have the data types like integer, floating, character, boolean, string, etc., which can be used in order to declare any variable. That means the type of the variable could be included in any of these in any of this data types, okay, and or in any of these types. And operators basically talk about the different types of operations which can be done using various symbols or various operators which are used in this particular language. Okay, suppose let us take the example that 2 plus 3. So here 2 and 3 are the operands and plus is called the operator. Okay, so they are basically the constructs which can manipulate the values of the operands. So first of all, let us begin with data types and eventually we will move ahead with operators. Okay, so talking about the data types. So first of all, let me write down the heading as data types. So talking about data types. So now each of the variable in Java, whatever variable we have used as of now, in our previous session also we have seen that we have used color and age as the variables, okay, to store the values of a respective bird. Now these variables, they definitely must be specified with a data type. In Java, the data types are divided into two groups. Okay, two groups. So this are basically, the first group is basically the primitive data type. So this primitive data type, it will include byte, short, short, then int, long, float, then double, then boolean, and character. So it is up to our decision whatever type of data we want to use in our, or whatever type of variable we want to use in our program. Okay, the second one is the non-primitive data. So non-primitive data, and this non-primitive data type, they include strings, arrays and classes. So we will talk about this in details in our subsequent sessions about the non-primitive data types. Okay, now here we will be primarily focusing on the primitive data type, and we will be seeing how these again are reclassified into two different categories. Okay, so first of all, let us take the example of the primitive data type. Okay, so we will talk about primitive data type here. So when we are talking about primitive data type, we have to understand that it specifies the size and type of the variable values, and it has no additional methods within itself. So one category we have to understand, or one characteristic we have to understand, that it is not based on any additional, no additional methods. There are no methods for it. Okay, we just have one word, keyword, to declare the type of data or declare the data type. So there are no additional methods involved. And in Java, as already discussed in my previous slide, that we have 8 primitive data types in this particular Java framework. Okay, so first one is the byte. I'll draw it in a tabular form so that it becomes easier for us to remember and also to make a note of it. Okay, so basically, so the first column of the table would be data type, the name of the data type actually. Okay, then we have the size associated with it, and we will also have a logical explanation, or also have an explanation for this particular data type. Okay, the first one we will talk about is byte. Okay, so byte is basically the first type of primitive data type that can be used in Java, and the size of it is 1 byte. Okay, so it stores whole numbers from -128 to 127. Okay, now the second type of primitive data type which can be used is short. Short has 2 bytes, which stores whole numbers from -32,768 to 32,767. So if you have a value for a size of a particular variable which exceeds 32767, you cannot declare it within short. Okay, now next we have is a very common data type which we have been using since the very first lab. So that is int, and it has 4 bytes. So 4 bytes, and it stores whole numbers from -2 like 147 483 648 to 147 483 647. So this is the range of data that can be stored within int. So most of our data is already covered in our int, but however, if we have to use some data which has a size of greater than 4 bytes, then we have to go for the long one. So let me first remove the others. Okay, so let me remove it. Yes, now if we are considering something which is greater than 4 bytes, then we have to use the data type as long, which has 8 bytes, and its size is to store whole numbers from -9223 372 036 854 775 808 to 9223 372 036 854 775 807. So this is the range of data that can be stored within long. Generally, most of our programs are based on int. I mean, most of the variables which we use in our programs can be satisfied using int data type. However, if you feel that no, you need a bigger range of data, I mean bigger range of variable, then you can go for long data type variable. Okay, then we have float. Now float is basically a data type which is capable of accommodating the decimal numbers, okay, or floating point numbers. So talking about float, float also has 4 bytes and it stores fractional numbers. We have to understand that up till now what we have been doing could store only whole numbers. So float is a data type which is capable of holding fractional numbers, okay, and it is sufficient for storing up to 6 to 7 decimal digits, okay, 6 to 7 decimal digits. That means if I have something like 5.7654321, so this can be accommodated inside float. Okay, so the next possible data type that we have here is double. So double also stores fractional numbers and it is similar to long. Okay, it has 8 bytes and this holds fractional values, and it is sufficient to store up to 15 decimal digits. So it has a huge range to store the digit valued numbers, okay, or I mean decimal valued digits, okay. And then we have Boolean. So Boolean is generally used in order to store true or false values. So it is just true or false values, and the size of Boolean is simply 1 bit. So we just need to identify whether it is true or false, and we can do that using Boolean. And the last primitive data type which we have is char. So char is 2 bytes. Char basically is 2 bytes, and it stores a single character or letter or ASCII values, okay. So it will be capable of storing a single character, as the name suggests, char, single character, or maybe a letter, or the associated ASCII value, okay. So I think this is clear from the primitive data type. We have 8 different data types, which is byte, short, int, long. Then we have float, double, boolean, and character. So from float up till double, float and double, these are basically used in order to store fractional values. Float is capable of holding up to 7 decimal digits, and double is capable of holding up to 15 decimal digits. Now these primitive data types again can be divided into integer types and floating point types, as I have already discussed, okay. However, let us write it down so that it becomes easier for us to remember. So this primitive data types can be classified into integer types, okay, integer types, and then we have floating point types. So integer types, it is very simple, because they can store whole numbers, positive or negative, such as maybe -7, then 48 or 172, etc., right. So they do not have any decimals associated with it. Some of these valid data types are byte, we have byte, then we have int and long. Now floating point types are those data types which represents numbers with a fractional part which contains one or more decimals, and basically it is represented using float and double. So double is the higher range of float. Suppose we have a number like 7.58 or minus 32.661. So all these numbers can be accommodated using the floating point data types, okay. And we also have some various scientific representations, okay, or a scientific number with an e can be associated in order to indicate the scientific number using the floating point data type, okay. For example, if we are using something like let's say 42 point, okay, I'll simply write it here. So let me also write here is that it is not only used for decimal data types, okay. It is not only used for decimal data types, but it is also used to represent some scientific representations, okay, scientific representations. Now if I'm taking a number like let's say 42 e and let's say 4 f, okay. So if I'm having something like this, then it can also be represented in the scientific format, okay, which is basically is equal to 4 2 and followed by 4 zeros, okay. Similarly, if I have something like 51 e 3 f, so this will give me 51 followed by 30. So this is just a scientific representation notation which can be um, represented using your floating point data type. Now this is all about the primitive data types. Now moving ahead, we will look into non-primitive data types. So non-primitive data type basically represents those data types which are called as reference types because they refer to certain objects. Okay, so non-primitive data types, we'll talk about this in details. Okay, right now we'll just simply talk about it, and later on we'll see these things in details. So non-primitive data types, they are called as reference objects, okay, or reference types, sorry, reference types, because they refer to some certain objects. Okay, they will be referring to certain objects. The main difference between primitive and non-primitive data types um, are that primitive data types or primitive types are predefined, which is already defined in Java. Okay, and these non-primitive data types, they are generally created by the programmer. Okay, they are created by the programmer and they are not predefined in Java, created by the programmer and are sorry created by the programmer and are not predefined. So this we have to remember. Okay, except for string is the data type which is predefined. So we have used in our previous program, right? I'll write it here as except string because there we used string color. Okay, so string is a data type which is non-primitive data type which is already predefined. However, as far as other data types are concerned, it is not predefined. Okay, that is your arrays and classes, and these non-primitive types can be used to call methods to perform certain operations. Okay, they were used to call methods. So you create a particular variable of a data type and they will be generally used in order to call a particular method. Okay, and these methods will have certain operations within them. It might either be simply printing the values of the variables or it might involve in some operations, but they are definitely used to call certain methods. Okay, and whereas your primitive types, they hold values, they hold direct values with which you can simply do the operations. Here you have to go via a method to perform the operations. Okay, and in non-primitive data types, the value could be null. Okay, however, in your primitive data types, the value is never null. It can be 0, but 0 is also a value, right? So it definitely has to, primitive data types definitely has to have a value. However, in non-primitive data type, there is no such hard and fast rule that there should be a value associated to it. Okay, the fourth important point that we have to remember is that the primitive type starts with lowercase letter, while non-primitive type starts with an uppercase letter. So in non-primitive, we can consider that it starts with an uppercase case letter, and in primitive data types just the opposite happens. The size of the primitive data type also depends on the data type, while in non-primitive types all have to be the same size. So the size is same for all of the data types within non-primitive, for all of them. Now you have to understand that these are just certain differences between primitive and non-primitive data types. However, the most commonly used data types are the primitive data types as well as some of the non-primitive data types, which are your string, arrays, and as well as your classes as well. So these things will contribute mainly towards the declaration of different variables, okay, or the declaration of various classes that you would like to create, okay. But the primary thing that you have to understand behind this operators, behind these data types, is that we have two different classes of it, or two different sets of it, and both of them has different utility, okay. So this is what we should know for data type as of now. In our subsequent sessions, maybe we will go deeper into non-primitive data types when we will do strings, arrays, and classes in details. Classes we have already seen, however strings and arrays we still have to check. So when we will be doing those chapters, we will be focusing more into how the syntax would look like, and how it is actually created, and how you have to declare it, okay. So in my next part, we will be discussing about the different types of operators which are used in Java. So thank you.